The last video discussed the fact that information is a key business resource, and it's something that's very, very important for businesses when they start to make decisions. Now we need to look at the relationship between information and data itself, because those are two different things. So we're going to explain this concept through what is known as the DIKW pyramid. DIKW, where D stands for data, I is information, K is knowledge, and W is wisdom. So each step up that pyramid answers questions about and adds value to the initial data. So data is the base, it's the foundation, it's the bottom of the pyramid that supports all of the other concepts that lie above it. So data itself is just simply a collection of raw facts in some unorganized format. So it's the building blocks of everything that we have on top. So a data point might be, for example, first name. Well, what does first name mean? We're not certain unless we have additional context that describes what that first name is. So the second building block in the DIKW pyramid is derived information. So derived information is something that is easier to measure, it's easier to visualize, and it's easier to analyze. And it allows us to add the context based on the building block of data itself. So when we start putting data together, we get information. So first name in my example in the last slide, first name is just a data point. But when we say it's the first name of a student, then we have a little more context. Now we start building information around that. So perhaps a student might also have a first name, a last name, a middle initial, maybe a suffix on their name, a prefix on their name. Also, perhaps they have a GPA, a set of grades that are associated with them, and so on and so forth. So now we have this piece of information called student that collects all of these data points together in a very specific way. From information, then, we can add the third building block and start connecting pieces of information together, where we start developing an understanding of how to apply that information to achieve some business goal. So relevant knowledge is the how. How are things connected together? Those pieces of information. So we have students and we have courses. So how do those students and courses connect together? Well, they connect together through their registrations in courses, and perhaps then we can start to say, okay, well, this set of students scored really well in courses, but these set of students struggled a bit in courses. And we can start developing knowledge based on those information pieces that are now connected together. And finally, the top of the DIKW pyramid is wisdom. So wisdom is the knowledge applied in action. So in the continuing example that I was giving, the knowledge that we now have from courses and students that are connected together, now we can say, okay, how can we implement an early detection system so that students who are struggling in particular courses can be contacted, for example, and perhaps assisted through the process. So now we have gained wisdom by acting upon the knowledge that we have in front of us. So data management is required to provide useful information. But what is data itself? Well, the word is old. If you look in Webster's 1828 dictionary, it's defined as things given or admitted, quantities, principles, or facts given, known, or admitted, but which to find things or results unknown. But I also thought information was the important part of business. Well, that's true. When we recall the DIKW pyramid, data is the stuff information is made from. So if we start looking at this in a different way, we can map it out a little bit differently than we previously said. So the DIKW pyramid shows the relationship between information and knowledge. So we may have knowledge about objects and so forth that allows us to say that there are certain types of information that we need, and we need that information to be stored, but we also have to have some sort of representation of that data or that information, and that's where the data and the raw facts come into play. You can pass that data through storage, through processing, through a database management system, or some other form of data storage. And then as you collect more and more data, that allows you to interpret it based on the representation of that data that you have stored. And then that allows you to gain information, new information, after you contextualize that data and interpret that data. And then information can then further be contextualized and connected so that knowledge is produced. So again, this is a process of breaking things down into smaller pieces. This is what we need on the left side of this diagram. We need to know this type of information, and then we need to break that information down into smaller pieces that are our data points. And then after it's stored and after it's processed on the right side, we have those data points which lead to interpretation, which leads to information, and then the interpretation of that information and the connection of those information items then leads us to more knowledge that we may not have had before. A couple of ways of looking at data is number one, structured data. So data that has a clearly defined data type, so it's a number, it's a character string, it's decimals, so something that is very specific and can be defined clearly. So data that, because of these data types and patterns of storage, is easily searchable. So we can look for integers with a certain set of parameters. We know that it's a number between 150 and 200, for example. So we can search using that term because the data type tells us that that's what type of data is there. Structured data is usually stored in a relational database. We'll talk more about that later. There are other types of databases that you might see, and some databases are a little more sophisticated than others, but generally speaking, it is a relational database. You might also now see more NoSQL databases. We'll talk about that later in the course. Unstructured data is data that has an internal structure, but that internal structure hasn't been predefined. So we can't say that this particular type of data is going to have this particular set of parameters. So data that, because of its lack of an external structure, is difficult to search. And that's usually stored in a non-relational manner, such as a NoSQL database, although it could be stored in a relational database. So generally speaking, structured data is stored in a relational manner, unstructured data is stored in a non-relational manner, although those could cross over a bit. So what is information? We've already kind of given a set of definitions for it. The resolution of uncertainty is what Wikipedia actually says about it. But it's defined really by two things. It describes the essence of an entity, so an entity is a thing that we can describe, and it also describes the nature of that entity. So this is what makes that thing up, and it allows us to describe it. So my definition of information is it's a grouping of data that describes an entity in a way that's meaningful. So information then, after we look at it, after we understand it, after we analyze it, that leads to knowledge. So what is data analytics? And here's kind of a diagram that shows this. We see in the circle there, it starts with descriptive, diagnostic, planning, prescriptive, and predictive. So let's look at each of these. Descriptive says we can use data to find out what actually has happened. Then we can use planning based on that data to find out what to do next. We can also use data to prescribe a course of action. We can predict what will happen in the future, and we can diagnose why something has happened after it already has been completed. So this is an analytic cycle, as we will see. But the data that we have at the base of this is the highest importance, and getting meaningful information from that data, getting meaningful knowledge from that information, and then gaining wisdom from those things is what data analytics is all about.